All right, guys, Mr. Antucci here, and in this third video, we are going to tackle calculating the confidence interval for a population mean. Now, to get into this, the first thing we need to remember is that the pattern is kind of always the same with these. You have point estimate plus or minus the margin of error. Okay, so this is the same basic format to creating a confidence interval. It's just the specific point estimate that we're using, mean or proportion, and how we calculate the margin of error is going to change a little bit. So when constructing a confidence interval for a population mean, we are going to have to use the sample mean of X bar. So the standard error of the sample mean, X bar, is an estimate of the standard deviation of the sampling distribution of X bar. So S sub X bar is equal to the standard deviation of this sample divided by the square root of n, or the square root of the sample size. Now this estimates this how much the sample mean typically varies from the population mean in repeated samples of size n. So again, when the random 10% normal large sample conditions are met, we can calculate a confidence interval for a population mean. And the formula that we have is our point estimate is going to be X bar plus or minus the T star critical value from a T distribution where the degrees of freedom are n minus 1, or 1 less than the sample size, times the standard error of the statistic. In other words, the standard error of the sample mean. Okay, so it's X bar plus or minus T star times the standard error of the sample mean. Now, again, they're not going to tell you the specific formula for a confidence interval for a population mean on the AP exam formula sheet. But on the formula sheet, you will have the standard error and you will have this general equation here for calculating a confidence interval, which is the standard error plus, or excuse me, the statistic plus or minus the critical value times the standard error of the statistic. Again, you need to know which ones to use in which context. Alrighty, so let's take a peek at an example. So we're piggybacking off of the example from the previous video where we've already verified that the conditions are met for calculating a confidence interval for mu, which is the population mean cost of an engagement ring for all US adults who bought one. So after adjusting for inflation, the mean cost of engagement rings in the random sample of 1,640 adults was $3,329. Standard deviation, 4,739. We want to calculate 99% confidence interval for the population mean. So first thing we have to do is calculate the degrees of freedom, which is n minus 1, or 1639. Now, in table B, there is no row for 1639, so we use the greatest one, the greatest value of the degrees of freedom that is less than 1639. So we would have to use 1000, and that would give us a T star critical value of 2.581. However, we are going to use it's not wrong to do that, but we're going to use the calculator value. So if you do inverse T, the area that you would put in is 0.005. Remember, we're doing a 99% confidence interval. And if you think about the 99% confidence interval, the 99% in the middle leaves 1% on the tails. So this is 0.5% above and 0.5% on the lower tail. Percent as a decimal would be 0.005. So we are going to get 0.005 degrees of freedom, or 1639. In the calculator, you can actually put in the specific one, and you get 2.579. Okay, so we'll use that as our T star critical value for our calculations in this example. And then we do uh, our formula here. So we take our sample mean, which is 3329, plus or minus the T star critical value, 0.2.579, times the standard error of the sample mean, so which is 4739 over the square root of 1640. And this is going to give us 3329 plus or minus 30180, which gives us a confidence interval of 3027.2, comma 3630.80. Okay. Now the question comes up is how should we how should we interpret the interval in this example? Interpreting the confidence interval is very, very important. So what we would say is we are 99% confident that the interval from $3,027.20 to $36,030.80 captures the population mean cost of an engagement ring for all US adults who have bought one. Now, as you probably guessed, because it says it right here, you can actually calculate a confidence interval for a population mean directly on the calculator from sample data or summary statistics. So we're going to bust out our calculator here, and the steps are going to be the same whether you're using an 83 or an 84. So once you have your calculator on, hit stat, arrow over to tests. And what we want to do is a T interval, which I believe is choice 8, a T interval. You can remember that because population mean confidence intervals use the T distribution. So we want a T interval. And we do not have the raw data here. We have the summary statistics. So we would scroll over to stats, hit enter. And then we put in the sample mean, which was 3329. We put in the sample standard deviation, which was 4739. And then we put in the sample size, which was 1640. And then we put in the confidence level, which was 99%, so 0.99. Okay. Now, if you did not have the summary statistics, if you actually had the raw data, you would highlight data here and have entered it. Look, if I click on it here, it's going to use the data in L1. So whatever list you stored the actual data values in, it can pull from that list. But we're going to do the summary statistics here because they've already given them to us. And if you hit calculate, it's going to give us the confidence interval. So our confidence interval, same thing, we got 3027.2, comma 3630.8 gives us the sample mean, standard deviation, sample size, which we already know. Okay. All right, guys, that's it for this one. Make sure you continue on to the next one. Take care.